Hey there, folks. Welcome back to another part of my thing where I am making a Tetris data extractor. Remember back at part 1 when I said we probably only need like 4 sessions? Well, welcome to part 12, because that's the way things go. Last time we were very distracted. A whole bunch of stuff happened, and someone was at the door, and there was a whole bunch of shenanigans happening, and I couldn't concentrate, so we ended up commenting out a bunch of code and messing around with a bunch of parameters and changing things just to get something to work. And so now I'm kind of scared if I'm going to look at the code again, because I can't remember all what I did, and I'm sure a lot of it was a very poorly executed, but that's okay. No one is scheduled to come ring our doorbell today, so hopefully we should be able to focus on cleaning up what we have and moving on. We were working on reading the actual Nintendo screen, and we kind of did a little bit. We read the score to some extent, but we didn't account for the side black bars that we removed. So we're going to have to deal with that. And I'm actually going to add that to the extraction model. And oh yeah, that's what I wanted to do. I wanted to rename this. I don't want to call this a Tetris extraction model. I want to call this a screen information model, because this is not just about extracting data. This is going to be all the data necessary for getting information about the screen. So we do have extraction points. Digit height and digit width. This is the full width and full height, and this is going to be reduced width. And reduced height. Okay, so the idea is we will keep track of all this, and maybe we can use it so we don't have to calculate it again and again and again, especially if we're doing this live from a video feed. So a little bit of future-proofing there. All right, let's see what I've changed, because I've changed a whole bunch. Oh, yeah, gross. Let's get rid of that. So we have I'm gonna change all extraction to info model. That should work. Okay. Digit width. Oh yeah, here we did this. So get the info model. All right, getting all the data. We want to take the bitmap and we want to create from it a screen information model, what used to be called the Tetris extraction model. And then from that, feed it into all the various methods to figure out the score and the number of lines and the level and all the piece counts. So let's make sure we're actually doing that. The first thing, this bitmap is the unfiltered, unedited version of our screenshot. And immediately we reduce it. So I think what I'm going to do is let's reduce it. What? Let's reduce it in the info model. We'll just throw it there for now. So the algorithm is getting all the data. In get all the data is to take the unedited bitmap and extract from it the info model. Model? No, that's not right. Get information model. There we go. From that, we can then feed it into all the different methods. So that's easy and simple. So let's focus on just getting the information model. So first we will reduce the bitmap. And actually, let's rename that to screenshot. We're just going to say far reduced, where we reduce the screenshot. Okay. Now character width. Let's bring this up here. Let's const number of, let's call it horizontal character count. And that is going to be an integer. And it is going to be equal to 32. We have a vertical. No, what am I talking about? Number of columns. Number of rows. And that we thought was 29, although I'm suspicious about that number, but that's okay. Okay, actually, let's make these floating points. Just so I don't have to cast it here. So the character width is the width of the reduced divided by the number of columns. That should be a float. Yep. And this is reduced. Oops. Divided by number of rows. That makes me feel better. Okay, now the screen information model. We have something called full height, and that's the screenshot height. The full width, that's the screenshot width. Then I've got something called the reduced height, and that's the reduced height. And reduced width equals reduced width. Okay. And then actually, let's take this for our character width. We'll throw that in there. Character height. digit height, whatever. Throw it in there. Okay, that looks cleaner. Is there anything else we're missing? No. So the screen information model has all the information regarding the original screenshot. It's going to have the actual dimensions of the playing field. It's going to have the number, the size of a digit. Then it's going to have points. And these points, I think, do I want them to be from the original image or the reduced image? And I think I want them to be from the original image so we can reuse this. And I think that's what I did. Let's open that back up. Actually, I can open this up in GIMP. Let's do that. The score I said was at 525 and 146. Yeah, that's right. So the position of the elements on the screen are with the black borders. And that's good. Because the idea is that we will... Oh, actually... what happens well, let's get this working. This is relevant to just my screenshot. When we resize the image, it won't work, but we'll come back and turn this into a column and a row. I think that's what we'll do. But for now, we'll just leave it as it is. Okay, so that's how we get the information model. Then the score comes along. And this bitmap you know what, I'm going to rename this a screenshot as well, because it just makes more sense. This gets renamed as a screenshot. Okay. So the screenshot is unedited. Here's the information model. Now we're going to get the value at the info model score y the digit width, the digit height, and 6. And then I want to change this to full width. Okay. All right. Yeah, this is just that single digit. Okay. Good. Good. Let's see if we can rebuild our solution. Huh. Data extractor could not be found. Oh no. Data. I renamed the namespace. Not a good thing to do. Don't do that. So this isn't a thing. Okay. So now I can rebuild this. Rebuild all succeeded. Okay, good. Now we're going to go to our data extractor tests and the Nintendo. Yeah. So let's debug this. And right now we're only concerned about the score. Okay. Go into this method. Okay, so we have our screenshot, and we're going to get our information model. So we have a full width, a full height, reduced width, reduced height, all of our points. We have our digit height and width. Okay. I'm actually curious. So this is getting the score. Be 126, that's odd. Oh well. I actually want to take the sub image, save it to testing3.bmp. Okay. And I'm doing this so that if something goes wrong, oh come on, we know exactly what we tried to read. Okay, testing 3. Oh, look at that, folks. That's pretty darn good. Okay. So, step out of that. So what is the score? 429283. Ah, interesting. Our digits aren't being chopped up properly. And I think, oops. I think that's because we're shifted over too far to the left. And so the divisions between digits are not so perfect. See, the issue is none of these pixels are black. I'm actually going to stop this, go back to the data extractor, See, if the digit width is 21 and there's 6 of them, no, that's right, that should be 126. I'm going to move the score over from 525 to like 527. Let's just have a look at that. Okay. Oops. 829283. Okay. That's not working out. Let's have a quick look. Every time we go through we get the digit image, we're going to save the digit image to something called current digit.bmp. Okay. We'll put a breakpoint right there just before we try and read it. I want to get my breakpoint window. There we go. Okay, so now we'll run the test. This is going to hopefully kind of work. All right, so the first digit that should be an O. And this is not actually reading as an O, it's reading as an 8. Okay. So that's different. See, that looks pretty good. Yeah, there's nothing wrong with that. I think what's happening is these extra pixels here see, really, it shouldn't be like this. These pixels are just blurriness. I'd really like to only keep these bright ones because it's messing up my data. Because if you recall, all I do is look at the black pixels. But anyway, this is looking pretty good for chopping up the digits correctly. There's another 2. What does this one look like? Yeah. So I don't know if I'm going to use like alpha values or what. See, that's pretty good. But again, all these are reduced images. No, wait a second, they're not reduced. Right, they're going to get reduced. But they don't look very good. Look at all of these pixels here. These are all non-black. So of course that's not going to be a 3. We have to put it through something that will 892283. So we recognize the 3s and the 2s. The 6s and the 0s look like 8s though. And I think 8 has the most pixels lit up. And so if you have a lot of noise all over your image, it makes sense that it would think that it's an 8. Okay, well, that's good to know. I'm happy about that. So what I want to do is I want to take the image, and instead of keeping all the pixels, we want to put it through a filter that will wash out very dark pixels. Pixels that are very dark should be treated as black. And I'm sure there's several ways of doing that. But let's go to our digit reader. Let's try converting the image to black and white. Not grayscale, but true black and white. Let's see if that's a thing that can happen. Come on. Convert to black and white. And we'll take the first answer from Stack Overflow, as always. See, not to grayscale. I don't want grayscale. Interesting. This answer says just use the green aspect of the color. No, see, I don't want a grayscale. I want black and white. We might have to come up with our own algorithm. Okay, so let's say see if it's very dark, I want it to be treated as black. So let's go through all three colors. Find the one that's lowest. Or should we find the one that's average? See, these values can range from 0 to 255, I think. Here, let's have a look. The bitmap. Here's a color. Oh my word. Get hue. What's a hue? Okay. From ARGB. Oh, here we go. Yeah, so the blue, red, and green are all bytes, and a byte is an 8-bit unsigned. So you get values from 0 to 255. So if I take the average of the blue, red, and green values, and they're below a certain threshold, let's say 100, then let's call that black. Oh, excellent. Definitely something. So now what the issue is you remember we had several isBlack methods. I've got it in image reducer and in the digit reader. So we need a new interface. I color check. I color check? Sure, whatever. And this guy's job, interface, is to just tell us if a pixel is black or not. And because it's going to be shared, we're going to use the same thing in all areas of our program. So, color check. Color checker. I don't know why I called it color check and not color checker. There we go. Okay. No, implement interface. Okay. So, whereas before, where is our digit reader? We had this private method that checks if a pixel is black, but I suspect that this is not what I want. So, if something is let's just, yeah. Or wait a second, because I'm thinking of the piece counts are red, right? So if something is fully red, the red value is at 255. Blue and green are at 0. When I take the average, I'm going to get something like 85. And 85 is less than 100, so I would call that black, even though it's like the brightest red that could possibly be. And I want to treat that as non-black. So I think what I'm going to do is I'm going to look at the value, like the maximum value. So if the maximum between the red, green, and blue is under a certain threshold, then we're going to call that black. All right, and I think the max function only takes 2. Math.max. Yeah, it just takes 2. So I'll have to do this twice. Oh well. Color red. Take the maximum of color red and color green. And then take the max of that and color blue. And it's black if it's less than 100. All right. Wonder if we could probably make a test function to convert our images. Let's just do this though. That's fine. We'll just see it work in the algorithm and hopefully. Okay, I've got digit reader. So we're not using the private method anymore. Is black. It's somewhere else in the image reducer. We're not going to use this anymore. Okay, so now I need a public color checker. So in the image reducer, we're going to need an eye color checker. And color checker equals color checker. And it appears I'm only spelling some of my colors with U's because I'm Canadian and I can never make up my mind. Okay. Color checker dot is black. So now we're going to use our new is black method. The digit reader I want to make sure everything's good. I am recording, right? I sure am. Awesome. Okay. Our digit reader has an is black as well, right? Where is that? Color checker. Somewhere there's an error. There we go. Oh, come on. It is black. Okay. Private read only eye color checker. Color checker. And this is what I was kind of afraid of. The blurriness of an actual Nintendo screen is going to make things a little bit more complicated. But this should help us out by creating a range of values black can be. Color checker. Okay, and now all of these things, oh my word, they're all going to be. So the image reducer now needs a new color checker. Oh, this needs a new color checker. What's wrong with the digit reader? What is wrong? Reducer, scalar, color checker. Oh. Now what's wrong? Image reducer, scalar, color checker. What is happening? Oh my word. I don't even know anymore. This is getting too complicated. We're going to redo all this. So the data extractor needs why doesn't IntelliSense work? New screen reader, new digit reader, new image reducer, new color checker, that's okay, new image scalar, that's okay, new color checker, that's okay, that's okay, new image reducer, new color checker. Oh my word. Whew, we did it. Yikes. Okay, what's wrong here? Oh, for crying out loud. Oh, and that's the emulator. Here. We're going to copy that. These are emulators. We don't care about those. This, that's how we make a new one of those. Dependency injection is going to take care of all that. But, okay, the name is black does not occur in context. Okay. Is that okay now? Is that gonna build? Yes, it built. Okay. Let's go back here. Where's my breakpoint? So actually, what I'm going to do, instead of, I'm going to say, do test stuff to the digit image. So this is just going to be a private method I'm going to eliminate. But what I actually want to do is I'm curious what the picture looks like when we make those pixels black. So let's loop through x is less than digit image width. Let's turn the image height. Let's pump the whole image through my filter and save it and look at it. So if digit image get pixel at x, y, new color checker. Okay. Color checker dot is black. And what we're going to do to the picture is we're going to say digit image dot set pixel x, y, and we're just going to do color black, which is 0, 0, 0. And once we loop through all the pictures, then we're going to say digit image dot save current digit dot bmp. And now let's see how much of the noise that gets reduced. All right, this is interesting. Okay, let's debug this. And the breakpoint will be hit after we shoved it through our filter and we saved it. So there's a lot less noise. A lot less noise. And before, we thought this 0 was an 8. And now we see it to be a 0. So this actually helped us. That's cool. Let's go to here. I want to just go to here. What's our final number? 029263. Ha! So it worked. We got rid of all the extraneous, stray, darkish pixels, and it totally worked. Now we'll cast that to an integer. And we'll get the green check mark. Ha! Okay. That's fantastic. I'm super pumped about that. So let's get the level and the lines. Those were relatively simple. This time we called it a screenshot. And we'll pass in our info model. Model? Come on. I did a string replace. Info model. Made my names funky. Screenshot info model. Okay. So where's my level here? You know what? I don't even need that. We'll just recreate it. Level. So then return screen reader .get value at. And now this is the screenshot. I'm going to pass in the level.x, level.y. This is the width and the height. Now this is not, this is the digit width and height. Okay, I'm renaming this. Digit width, digit height. Does that get saved? No, I called it character width. Well, yeah, you know what? It's okay. It can be character width there. Okay, so info model dot digit width. And the level is always 3 digits. Okay. Let's see this. So in the screenshot, the level we got to was 18. Let's go back to our tests. And bring that one back. So the score should be that, the level should be 16. Let's just put a breakpoint there. Debug this. What are we at here? 50 minutes? What? Lines. Oh, right, the lines. Instead of level, It's lines. And the line count is 3 digits as well, right? Oh, the lines is 3 digits. Oh, the level is only 2 digits. What am I talking about? Nobody can get to level 100 unless you're a computer. Okay. All right. So that's good. Go back to our test, and the lines needs to be 103. I think all of these are old. Oh well. Keep them there. Okay, let's debug this now. Interesting. Lines expected to be 103, but found 12. Okay. Well, let's see what it's getting here. Let's put a breakpoint here. Actually, we're going to be doing this a lot. Let's take the sub image and just save it as current element .bmp. Okay, and then we'll run our test again. And we'll see what our algorithm thinks is 12. So we should have a file called current element. Here it is. Oh, that's 18. That's for the level. Okay, never mind. That's okay. This is that's totally right. Oh, because the lines are 12. What am I talking about? I was looking at the wrong screenshot. This is totally right. 100% right. Okay, let's go back to our tests. I'm using the wrong screenshot. That's why. 12. Okay. And the level should be 18. There's no. So this should just totally run. I've got the score, the lines, and the level. And there it is. So that is everything that one needs to do really cool stuff. So actually, I'm thrilled. But let's get these piece counts going. They're going to be a bit trickier because not only are they red, but they kind of bleed into each other. So, yeah. Let's just do it. Okay, let's bring them all back and we'll recalculate or put the right values here. Okay, what do I got? 7, 6, 7, 2. These are not very exciting. There are lots of zeros in this screenshot. There was another screenshot I had. Where was the other screenshot? was a very poor screenshot as well. Oh, that was 2. Oh, where did I get the other screenshot from? Whatever. Okay, we'll just use this one. 7672775. 7 6 7 2 7 7 5 7662 7672775 7672775. Okay. All right. Let us get all of this now. It's going to complain. Screenshot info model. This is big news. Like, we're almost there. All right. These are all 3, so we're going to use this. Oh, someone's at the door. Okay, we're back. So this is not lines, this is the Z point. Z point. So here now I'll copy this. Change the... no. Z to T. Okay. These piece counts might not work. What I don't really care about them though. The only interesting one is the long bar count. But the fact that we read the score and the lines, it's really the score and the lines that all I care about in real life. This is I. Could make this a little cleaner too, since all these things are doing very similar. Very similar things, and they're all passing in nearly the same parameters. Clean up that file a bit. Okay. Now let's see what happens. Let's just see what happens. Let's put a breakpoint here. And we'll debug it. Oh, I've got a breakpoint here. Okay, folks, we did it. So, score 29263. What are the lines? Lines are 12. The level is 18. The T number is 7. J is 8. Okay. The Z is 7. The O is 111 O's. S is 7. L is 7. I is 5. Why? Why is the O 111? I think I feel like that's just wrong. What happened to my O count? What did I do? What? What's wrong with the O? Huh. Okay, let's put a breakpoint here. And I get rid of all my other breakpoints. So we sort of are close. The problem is those piece counts are so low. But at least it's recognizing the 00 in front, which is actually fantastic now that I think about it. So here's my O. My X is 148, 241. Crop area. So let's take a look at the current element now. Oh, fantastic. Check it out. That's what it's trying. Well, that's a problem. I got my Y coordinate wrong. Let's open this up and we'll have a look at what that Y coordinate is supposed to be. So it really should be 338. Somewhere around there. What did I have it set as? $241. Huh. Maybe 341? Oh, that's my problem. Yeah, that 241 needs to be a 341. Okay. So now that should work. What was the other thing I was failing at? Well, I guess we're about to find out. Just run it. What? No, it didn't work. Right, okay. So the J, we expected it to be 6, but we found 8. So let's go into the J. No longer the O. Let's go into the J, wherever you are. There we go. Breakpoint there. Debug this test. This might be the only one left. And I knew the piece counts were going to be funky because they're red. They're a really odd color. Okay. Let's look at what we think is the piece count for the J. See, it's so difficult. So then we recognize the digit 0. We recognize another digit 0. And this is where we think it's an 8. So we'll save it. Let's look at the current digit. See, that's why. So we're keeping I think we just didn't go far enough. Let's have a look at what it is before we run it through our algorithm. So let's save it first. Okay. So what we're going to do is we'll see the 6 before it's filtered. Then we'll see the 6 after it's filtered. So the first one's a 0, the second one's a 0. Here we go. Okay, so this is the 6 before it's filtered. And I have trouble thinking that that's actually, that left-hand one is part of the 6. I have a hard time believing that. Yeah. And so then we run it through our algorithm, save it. We get rid of all those like fake pixels that aren't supposed to be there. But this is still part of the 0. I think that's part of the 0. I think we're not... yeah. Let me look at current element. You see, yeah, we're starting too far to the left. I could actually make all the 148s to maybe 149. Let's do that. Where's my thing here? So let's change all these to 149. I think that will help us. Okay, so we'll save that. Let's still have that. Okay, let's have a look now. Let's just run it. We'll see what happens. I expect the J to work now. Ha! It took 1.2 seconds to do that, though. Oh, but we're saving a lot. We're saving a lot of, we're saving the sub-image here. We're doing test stuff. All of this stuff. I don't need this anymore. So now I should be able to run this in less than 1.2 seconds. Saving files and loading files, that's the slowest thing a computer can do. 1.1 seconds. Yeah, okay. That's okay. I needed it to be a bit quicker. With this entire get information model, let's actually put a breakpoint here and see how long that takes to actually calculate. Because that is only going to be necessary to do once. We don't need to do that for every frame of our video. For 33 milliseconds. What? Oh, no, I'm confused. Yeah, there's a lot of stuff going on. I think we're okay though. Like let's not diminish what we've done. We've actually read a Nintendo screen. I call that a win. There's still a lot that we have to do, a lot to deal with. Next time we're going to turn the XY coordinates into row columns. Hopefully that's going to work. We'll see. But yeah, okay, this is great. Thanks for joining me. Have a good day, and we'll see you next time.